Okay, so basically what we're doing today is a pre-recording or recording again the lecture of the other day, but faster, no? Okay, I'm probably going to do that in 5-10 minutes. So this is the problem we're doing the last lecture in class. So it's this one over here. Basically, through the procedure, I think it was pretty clear. The first thing we did, I think, was to do a cut between. So first calculate the cross-section properties, okay, and then we decided to do the first cut between 2 and 3 and calculate the shear flow deformation, okay. And when we did that, we found the area moment of inertia. We did the first cut between 2 and 3. We found Q23 equal to 0. And then we substitute into the MATLAB code, and we have the value for 3.4. Then we did 4.5, 5.6, 6.7, so on, so on. But then we got to step 2, and that's where we started to struggle with basic trigonometry. All right. So basically, we got to this point here, step 2, which is define the shear flow. So we first define the shear flows, and then in order to take the moments, the externals, we decided to select point A and then to go around. So 1, 2 wasn't a problem. All right, so let's see. I don't have the figure in front of me. Let's do this. Yeah, that will work. So as you can see, because the force was going through the point A, that means that the moment created by the external force was equal to 0. Okay. Then we started to go around and we said, okay, Q81, we did whatever this is the measure. So Q81 times 60 times the full R, which is 480 from here, or from point A to this bar. Then we had the problem with the area A12 that we needed to calculate. And here with A34. So basically what I did over here is that we double check the values. I got tired of checking the basic trigonometry. What I did is that I went to FEMA. I created the points. All right, let's see if I can undo this so that will be on the video at least. Let's see. Okay, so it's not undoing, so maybe I can go here, delete, geometry, surface, whatever, this one here. Okay, so what I did basically is just come here to geometry, create the points.
You can't see it.
Oh, sorry for that. Thank you. So what I did over here is just to go to, this is so hard for me now to do. I cannot see, so. I mean, you go to geometry on top, it's going to be impossible for me.
Those P, you can cycle
Windows P. Windows P. Then what happened?
like look at the center of the screen.
I mean, what happened is that that's my screen.
No, like if you, so you can put them both so that it's mirrored and then switch back immediately to the extent.
That's not what I'm doing. Okay, so what should I do here? So I have project. Anyway, let's go over here, I guess. The way over here, let me know if I'm on the right place. Is that geometry over here?
Yeah.
So you go to geometry, I think should be somewhere called points. I don't know where it is. Is it points somewhere? So you come here and you create the points. I mean, you can come to different methods. What's the mouse here? I lost the mouse. Here we go. I guess what is this here? I guess method probably locate. And you can put the coordinates and you can create all these points, no? Okay, that should not be difficult. Then you go to, let's see, what did I do? Geometry, I cannot see again, so help me. Is that geometry? Is the one with surface? I think here, no? Is that correct? So I went to corners. And then here I just said, I think that's why you had this one by default. No, on point. I think the area for us was from here, to here, and back here. That creates the surface. And then what I did is, I have no idea, is it here tools?
Yeah.
Is it a measure at the bottom or something like that? This one?
Yeah.
So measure surface area. I came over here, selected that one. And 20,400, no? Obviously, I'll show you now the MATLAB code. And then the other one we needed to calculate, I think was the one from this edge over here, so we could do the same thing. So help me a little bit here again. So geometry. What is surface? Let me know. Here, no? Yep. Surface corners. And I think the one we need here is, let's see, which one is it? This one from here to here. Is that correct? No, we need it. And again, I did again tools, I guess tools. Measure surface. I think that one we agreed pretty quick. That wasn't difficult. 6,000, no? Okay. So then what I did is just let me. Then I went to the MATLAB. Oops. Okay, here we go. This is a MATLAB code we were using. If I can make it a bit smaller. Okay, that's not what I want to do. Maybe it doesn't matter. Let's look at it from here. I was trying to move it there. But basically, then I went to the areas. Let me know when the area is that the areas. Okay. So basically, I can let you know where on the piece of paper here what I did. On this one, basically what I've done is that I think somebody actually sent me a PDF file, which helped me. Okay, I don't know who did it, but it helped me. So instead of looking at everything, I just took this. I took this area here. Okay, so if it was this big rectangle and eliminated this triangle here, and this triangle here. Okay, and that's how I got the 20,400. So again, that's what you have here on the MATLAB code. This is what you have here. And then that's it. I think after doing that, I can see what I did here. Okay, so you have the external, internal moment that creates the equation, and I solve for Q sub naught. All right. So we can go back to this figure over here. So we can copy it and finish it. All right, so here we go. So then I equate the external moment to the internal moment. I get the equation over here that if you want, you can copy, which is the minus 194,400 Q sub naught. This stuff I got it from MATLAB. I don't know why this shows up here. Let me move this to the other screen so you have to see it. Okay, so basically, let me execute that one. Executed that file. Oops, let me remove the file, this one. Let me remove that one for now so you can copy. But basically, from the MATLAB file that I showed before, I got the results over here, okay? Q sub naught equal to this. So I'm gonna have in all those results over here.